Lab 3, magnetic field of a bar magnet. This lab will go over an intro, fundamental principles, experiment slash the initial conditions, the glow script code, and then finally the follow-up questions. So this lab has multiple purposes. The first one is how the magnetic field of a bar magnet is affected by distance. The second one is the comparison of true distances to predicted distances obtained by the Biot-Savart law. And the third purpose is to understand how magnetic fields work through a visual representation. And so some of the results that I got at the end of this lab is that the magnetic field at the 45 degrees at distance D is equal to 3.68225 e to the negative 6 in the x direction, and then 1.10468 e to the negative 5 in the y direction, and that the magnitude of the magnetic field at 45 degrees was 1.1644 e to the negative 0.5. So some of the fundamental principles that we see within this lab include the magnetic field of a dipole, specifically when it is off-axis. We also use the dependence distance formula because the magnetic field due to a bar magnet falls off with distance, and so this is the way that we can express that. And then we use the linearization formula. And this is important because it is difficult to tell exactly what our experimental value of n is without using some sort of curve fitting. And when we plot ln of v of x versus ln r, we can find our experimental value of n. Experiment slash initial conditions. So the first thing we did was determine and compensate for the magnetic north by ensuring the x component of the app reads as close to 0 as possible. Then we aligned the meter stick to the bottom of the phone so it goes from east to west. We then found the location of the magnetometer chip in the phone, first by finding where the absolute value of the x value is at a maximum and the y component is at a minimum when the phone is held perpendicular to the meter stick. Then we rotated the phone by 90 degrees and found the max in the y and the min in the x. And then where these two spots intersected is the location of the magnetometer chip. The initial conditions included that the phone is aligned with the magnetic north and the magnetic bar is aligned with the magnetometer. And then system and surroundings, and the system was the bar magnet, the surroundings were everything else. And then some potential errors that could have occurred is that the phone was not completely aligned with Earth's magnetic north. So after running the experiment, these are my findings. I inputted what's in yellow and it outputted what's in blue. And then we can see that in the graph that once we linearize the equation, we get that it's negative 2.9955. And this is our experimental n. And this is really close to what it's supposed to be, which is negative 3. I also found that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And then as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. So this is my glow script code to show computationally what we did experimentally in the lab. And so the first thing that's highlighted in green shows the magnetic moment of my magnet. And I calculated this value by using the intercept of lnk. The next thing is the magnetic field, and I just plugged in the equation of the magnetic field in the next set of code. And then on the right side, I did the 2 arrows to represent the magnetic field on axis. I changed that bit of code. And then finally, I did the 4 arrows to represent the magnetic field on the perpendicular axis. My last bit of code, I edited it to show the magnetic field when it's 45 degrees off axis, and these are the results that I got, and we previously discussed some of the results earlier in my presentation. But yes, this is how all my code run and the results run. What if you hadn't ordered your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The magnetic field would have a lower value because the axis readings would have been obstructed by Earth's magnetic field. And then what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your experiment to differ? I would expect that the magnetic field would be stronger, but the direction would be the same.